All right, ladies and gents, boys and girls, we are at the final lesson of our unit. We're going to do a quick review here because this week's quiz is going to incorporate everything from Chapter 7. Before we go on and do a quick review, these are the formulas that you're going to need to know. Typically, you would have to memorize these because you wouldn't have access to them. But luckily for you, you are at home, so you will have access to these formulas to help you solve the unit test or the unit quiz that we're going to do this week. A quick rundown of the formulas. Number one, we have Pythagoras' theory, a squared plus b squared equals c squared. You can only use that when you've got a right triangle. Should have that little symbol in the bottom, the little square, and you can find any side of a missing right triangle. Make it a little bit better. Number two, the circumference of a circle, c equals pi d, or c circumference equals pi times the diameter of the circle. Number three, area of a rectangle is length times width. Area of a parallelogram, base times height. Area of a triangle is 1/2 the base times height because it's half of a parallelogram. Remember, don't forget to take the base times the height and then divide it by 2 in the end. This is the most common mistake that people make, is that they forget to divide it by 2 in the end and they just go base times height. But that would be for a rectangle, remember. And finally, area of a circle is pi r squared. Pi times the radius squared, or radius times itself. All right, let's do a quick practice on each one of these before we move on. Looks like today we've got a triangle. It's a right triangle. And we're going to use Pythagoras' theory. Remember, that's a squared plus b squared equals c squared. That's to find one of the missing sides. In this case, it looks like we're missing side A or B. It doesn't really matter which one. Let's just say it's A. That would be a squared plus 11 squared equals the hypotenuse, which is 15 squared. That's a squared plus 11 times 11, which is 121, equals 15 times 15, which is 225. Then remember that we subtract 121. This is the algebra part. And we get a squared is 225 minus 121, which is 104. And then we square root both sides. And we get a is the square root of 104. And if you're not sure what that is, use your calculator. It's going to be really close to 10. But if you want the exact number, hit the square root of 104, and you get 10.19 or 10.2. So this side would be 10.2 centimeters. All right, that's Pythagoras' theory. Moving on. Distance around something is called the perimeter. We talked about that early on in this unit. Just add up all the sides. Don't forget, these sides are equal. So you would have to add 14 plus 3 plus 14 plus 3 to give you a grand total of, I think, what's that, 34 centimeters. Notice it's just centimeters, it's not centimeters squared, because we're only looking for the distance around the shape, not the distance inside. All right, let's move on. Circumference of a circle. This circle looks kind of oblong for some strange reason. I don't know why. But it's c equals pi times the diameter. 3.14 times, in this case, 12. So take your calculator out. It's going to be right around 36. 37.68. And again, this is just going to be centimeters, not centimeters squared, because it's just a linear distance all the way around the shape, not an area inside the shape. Next, area of a rectangle. It's pretty basic. Area is length times width. In this case, would be 9 times 7, which is 63. This will have squared units because we're talking about the space inside the square. We're not talking about the linear distance around the square. That's not what we're looking for. That would be the perimeter. The perimeter of this would be 9 plus 9 plus 7 plus 7. So that'd be 28 and 14, which would be what? 42. But that would be the perimeter. Area of a parallelogram, again, area is base times height. It's almost exactly like length times width. Just remember that we are not using the diagonal. We are using this one here that's straight up and down. 8 times 20. So 20 is the base, and 8 is the height, straight up and down, perpendicular, and 20 times 8 is 160. So this would be 160 centimeters squared. Next, area of a triangle. Remember, our triangle is half of a rectangle or half of a parallelogram. So the formula for this is area equals 1/2 base times height. We would need a height here. Usually it will be given to you in a dotted line, possibly. Let's say that this one is 18 as the height. This would be 1/2. Don't forget to divide it in half of 20 times 18. So that's a half of 20 times 18. 20 times 18 is 360, and half of that is going to be 180 centimeters squared. Again, don't forget to divide it by 2. Area of a circle. This is a really goofy looking circle. Don't know why it's oblong like this. It shouldn't be, but our screen is distorting it. Area is pi times the radius squared, or pi r squared. That's 3.14. Times, in this case, 5 squared, which is 25. That's 3.14 times 25, which is 78.5 centimeters squared. All right, moving on. Here is where the trouble starts. Can we use this to find way more difficult questions? We're going to have to use multiple skills here. So let's start out with the easy one. Let's see if we can find, well, the first thing we're actually going to need to do is find this height, because we're going to need it to find the rectangle. Now you're going to have to use the numbers that we have to help you out. We've got 60 and we've got 40. If this whole distance is 60, sorry, and this distance is 40, then this distance must be 20, because it has to make 60. So if this is 20, and this is 25, then we can find this height right here by using Pythagoras' theory. So that would be a squared plus b squared equals c squared. And a is 20, b we're trying to find, and c we know is 25. So we're going to do a squared. 20 times 20 is 400, plus b squared, we don't know, is 25 times 25, which is 625. Then I'm going to use algebra. I'm going to subtract 400 and subtract 400. That's going to give us b squared is 225. And then I'm going to square root that, and I got b is the square root of 225, which is 15. So that gives us this height. Once we know that height, that's important, because now we can use the height to find the area of this rectangle. It's going to be 40 times 15. So that's 600 centimeters squared. That's this big blue rectangle. I'm going to have to subtract the area of the hexagon later on. Or is that an octagon? Yeah, it's an octagon. Okay, so I'm going to have to subtract the octagon after. I'm going to find the area of this triangle next. So this triangle over here has a base of 20 and a height of 15. So that's 20 times 15 divided by 2. That would be 300 divided by 2. This area is going to be 150. And then the hardest part, probably for most people, is to find the area of this octagon. And I'm going to just put a dot in the middle. I'm going to make a little triangle. I'm going to find Luckily, it tells us that this has 5 centimeters. All of these are going to be identical, and there's 8 of them. I just need to find the area of one triangle. Again, I need the height of the triangle. Luckily for me, the height is right here, half of 15. So the height is going to be 7.5. And the base is 5. So I'm going to take 5 and times it by 7.5, which is 37.5, and then divide it by 2. Each little triangle is 18.75. I'm going to write that in here. And I have 8 of them, so I'm going to times that by 8. I'm not even going to round it off yet. I'm going to leave 8.7 or 18.75 in my calculator and then times it by 8, and then I'll round off in the end. I don't have to. It's exactly 150. Okay, now I think I have all the numbers I need. I need the total of this big rectangle, which was 600. I'm going to add the 150 of the triangle. And then I'm going to subtract 150, holy smokes, it's the exact same amount of the parallel or of the octagon, and those should cancel each other out. So I would have a total of 600 centimeters squared here. How wonderful. If I didn't mess up. Here's another odd shape. Again, this is just a combination of all the stuff that we already know. I would do the easy stuff right away. I would find the area of this rectangle, which is 25 times 5. That's going to be 125. We know the height of this circle, which is 5 centimeters, because it says so right here. So this halfway across has got to be 2.5. So then I could find the area of that circle easy by 2.5, squaring that or timesing it by itself, and then timesing it by pi, which would give me 19.6. This large green triangle on top, I take the base of 25. I need to find the height. I don't have it, but I do have the hypotenuse, and it's a right triangle because it's on top of a box or a rectangle. So I'm going to use 25 and 28 as the hypotenuse and find out what this height is, which is side A, it looks like. So I'm going to use Pythagoras' theory, a squared plus b squared equals c squared. I'm going to do that quickly on my calculator here. And I get the square root of 159, which is 12.6. So this distance is 12.6. I did that again by using Pythagoras' theory with 28 and 25. It doesn't look like 12.6, but my picture isn't drawn to scale, clearly. Then I'm going to find the area of that triangle by 25 times 12.6 and divide it by 2. That's 157.5. Then I would just have to find the area of these two circles. Again, they're identical. That's why this little symbol is up here and they match. So I'm given the diameter is 4, which means the radius is 2, which would be from there to there. So that's going to be pi times the radius squared. Radius is 2 squared times 3.14. So it's basically 4 times 3.14, 12.56. I'm going to round that off to 12.6. And this is the same. So in total, I'm going to take my 125, area of the rectangle, add it to the 157.5, and then simply subtract the circle because it's not shaded. So I'm going to subtract 19.6 and subtract 12.6 and another 12.6 because there's 2 circles up top that are not shaded. That should give me my grand total. So let's see what we get here when I add them up. and I get 237.7 centimeters squared. All right, that pretty much concludes everything we've done this unit in a nutshell. Hopefully it's pretty basic for you at this point. There's lots of things that we've talked about. All of these formulas would be working together. One other thing that we haven't spent a lot of time on, but if you ever see a circle and it's only a half circle and you're given the distance, you can easily find the area of this circle by taking the radius, which would in this case be 5, squaring it, pi r squared, and getting 25 times 3.14, which is 78.5, and then just divide it in half in the end, because you've only got half a circle. So that concludes this part. Hopefully you aren't struggling with anything. If you do, let me know. We can try and work through some stuff. Good luck on Friday on the quiz on all of this stuff.